Well, hi, and thanks for joining me here in my shop. So I've tested the tubes in this radio. One of them has come out really low, really low. So I'm going to get rid of it, and that's this one here. It's number 6 rather. I'm going to put in a spare one that came with the radio from the owner. This one also tested poor, but functional, I think. So I think with this in here, there is a set of reasonably functional tubes in the radio and a set of fairly good tubes in the amplifier. So I think the name of the game is to try to get this to operate, and that's going to force me through a whole bunch of considerations as I work towards that. So first of all, just plugging the units together in a way that doesn't strain the cord at all. Let's see. So it's got two of these pins, so it actually goes in this way. Spin this around here. I'm going to plug it in. Plug that in. Okay. Just going to move the radio over this way. Okay, the speaker has a similar great big honking plug on it. Okay. Now the reason I'm willing to do this is because the owner has told me that the amplifier largely works, but the radio didn't work well. He didn't seem to care too much about it, actually. And I think we already know one reason why this radio wouldn't work is the tube that was in there is just a bad actor. Okay. Some other considerations: how to supply power to this thing. Now I've got it kind of in a position here I can't really move it too much, but I have another camera here. We can look down on it. We'll do that. Okay, so you can see two plugs here. One looks like, an outlet you would plug something into, and the other thing looks like a plug. It's got the prongs here. So I would guess that this is the power input here. And the other is the plug into which you would put the record player for powering the record player. Pretty sure of this because I did a little checking underneath actually, so I've got a pretty good notion as to how this is. So let us gamble a wee bit here. A very wee bit. I'm going to attach my cheater cord here. I'll be plugging this into a transformer, an isolation transformer, and I'll be running power through a couple light bulbs. I just can't quite see in that view. Through these two light bulbs. Now I'm just going to make it one light bulb to start with, so we're really going to restrict it. And this is a pretty power hungry guy here. He's going to be looking for a lot of power, so probably when I hit the switch, this light is going to come on very bright and probably stay that way for quite a while. Might even be hard to tell if there isn't in fact a short inside there at first. And with a reduced supply voltage means a reduced voltage to all the heaters. It takes quite a while for the heaters to come up to a temperature where the emission on the cathode starts to really happen. So slow, slow, slow for sure. Maybe I should figure out the on-off switch and stuff like that too. That might be a good idea. I mean, that's why I'm doing this, right? To force me through it. So we just look at the radio for a minute. The tuning is done like this for fine tuning, and you just slide it by hand to do the coarse tuning. Isn't that nice? It's really a neat idea. It works really nicely. It seems to, anyway. I might be skipping a little bit, but you know, these are friction bearings and stuff. Okay, that's good. And we got a control here. Okay, there's a switch going. Okay, this must be a not very consistent. Okay, so I'm not going to be able to guess at these. Oh, it's another really feels terrible, but you know, it's a really old machine, so the switch, maybe this is how the switch is supposed to feel. And then there's a switch down here. No labeling on this. Okay, so I'm going to take a look at the manual and sort out what these are before I get myself in trouble. Okay, so it's not too complicated at all. This is the volume switch, volume control. It sure sounds like there's a switch in there. It's very stiff, very, very gooey, really hard to turn. This is the switch between running the record player and not. I guess that would be record player. That would be not. This is the on-off switch, this toggle that's hidden down here. We'll switch it to the left. That's probably off. I think we're all set here. I'm not sure we can get any better. Maybe if I can get this guy up where we can see it. That might be helpful. Sort of see it. Okay, now do we need any test equipment ready to go? What about the antenna? What about the antenna? Well, you're not going to hear a darn thing without an antenna, so I should do something about that. My option is to use a real outdoor antenna, or use a piece of test equipment. Maybe at this point we just use an antenna. Just start with the radio being a radio. So antenna comes in to the shop over here. I've recently done a little fiddling with my outdoor antenna. That's what this actually leads to, along a mile of coax. It says antenna ground here. It's like I'm going to leave it not connected, but I'll be ready to connect it. Antenna and ground. Can these fit on here? Yeah. Okay. It's just two terminals right here. And on the other side, this is the input for the phono. So eventually we can input a test audio signal in here. Check out the amplifier that way if the radio doesn't get anywhere at all. So we're ready to turn it on. And the first thing I'm going to do is go down and switch on my antenna, which is not switched down to the shop here right now. So I'm going to run and do that. Okay, so just before I turn this on, I'd just like to explain my thinking around turning something like this on with having hardly checked it out at all. I have looked underneath this. I have not looked inside this. One reason I will turn this on is because the owner has told me that he runs it regularly, so there's not too much to be afraid of here. Secondly, I find with radios of all sorts, including something like this, if you don't find out what condition it's in when you first get it, then as you work on it and then you go to test it and it still doesn't work, you have no idea if you're the one who bunged it up or not. You can't tell if you're going up or down or what. You kind of need a starting point. So now in the odd radio I will not do this with, but the vast majority I turn them on as they are, in the condition they arrive in, unless there's something egregious about them. So I do this safely by doing two things. One is an isolation transformer. That's not really so important. It's using these lights to block the amount of power that can go into the unit that I'm testing. So these are called dim bulbs. Jump on Google and read up on dim bulb systems or things like that. I really like this. There's another whole approach which you can use a variable output transformer, a varactor or something like that, and you can raise the voltage up and down, and that's another approach to doing this. But I like the light bulbs because if things are wrong, they scream out at you something is wrong. Okay, let's see if they will scream out at me. Now remember, I'm just working on this is a 25 watt light bulb. And this unit is going to try to pull 100 watts, so you can kind of see what's going to happen here. This light will probably come on and stay on full. Okay, just giving my brain a chance to talk to me. No, my brain is saying nothing. Good. Okay. I think we're ready. So when I throw this switch downwards, it engages the lights, and when I throw it upwards, it sends the power directly to this outlet here and on to whatever's on my bench. Okay, this little guy is going to give me a chance to look at what the voltage is that's making it here. If there's enough voltage to even operate this little gizmo here. Okay, that's enough talk. The switch, I believe, is off. Here we go. Okay, perfect. Nothing happening. 124 volts showing up here. Because the switch is off on the front, the entire voltage shows. No current flowing, no lights on. So what I'm going to do, I'm going to turn off power. I'm going to turn the switch the other way. Okay, I'm going to hit the power. This time my eyes are really glued to these lights, but I'm pretty sure it's going to come on really bright. There we go. Sure enough, that is quite bright. I'm not nervous. I'm letting it run. So this guy's just coming on over here. Not enough voltage to operate this. So in that case, I have backup meters here. The meter I need to use is this one right here. So this is I don't know if you can see the pointer on it. This is a percentage meter reading percentage of full line voltage. Full line voltage 125 volts. We're running about 25%, about a quarter. So what would that be? About 30 volts. So I've got 30 volts making it in here. 30 volts, not going to do much. Now there's a little light that's come on here. It looks like a great big light bulb in there. Look at that. Wow. Okay. So that came on. Why did any of the tubes heat up at all? Hey, is there any sound? Yeah, let's keep the volume turned up now. Zero sound. Is there any heat in anybody? Nothing is lit up. So, but the light is on. That means the power is making it there. So what I'm going to do now, I'm going to increase the voltage supply to the radio here by screwing in the second light bulb. That's simply going to raise the voltage here to somewhere probably because this is such a heavy draw, probably to around 80 or 90 volts. Let's see what happens. Here we go. This might make everything come on too. You can see this is lit up really nicely now. Okay, I'm just gonna cut back the light here and start looking for filaments coming on. Okay, no filaments yet. This must be an incredibly bright light when all the supply is here. There still is not enough supply voltage here to operate this little electronic box. And if we check out the percentage we're about 60% of 125. That sounds like about 75 volts. We're getting pretty close to where this should operate. I still see no heating in here. From here, my next option is basically full power. Why would I hesitate at this point? The light bulbs, it's not so apparent in the video, but the light bulbs are not fully lit. There's not a dead short here. If there was, this light wouldn't come on. I don't think there's much here to be concerned about, really. If something bad was going to happen, it would probably be happening already. But none of these tubes are functioning yet. Why are they all? Not one of them shows any. No, wait a minute. Let's just get a little darker in here. I can't get any darker than this. Well, no hint of a filament yet in there. Okay, put the volume part way up. Full power is coming. Oh, I almost knocked my whole shelf down. Okay, all the filaments are lit up. They're all lighting up. Sound of the speaker. Shh, quiet. Crackling sound. Crackling sound can be from quite a few different things. Heat expansion in the tubes, tube pin contact, failing components, bad volume control, all kinds of stuff can cause this kind of sound. What we're going to do is we're going to flip it. I think it's on radio right now. I'm going to flip the switch to what I believe. We'll put it onto the record player input. Volume down. Oh boy, I didn't like that. Did not like that. That was not good. That was quite a whack onto the speaker. Let's go back. Speaker's gone silent. Oh! You know what? There's a problem here. Okay. Okay, we got a problem here. So what I saw, and I doubt you could see it, maybe if you watch the film over again you might be able to see it, is what's going on in this cone. So when I threw that switch and we heard that strange pop, it sounded to me like the cone being thrust to a limit. When I flipped the switch and watched the cone, sure enough, that's what I saw. It didn't pop and come back, it popped and held. So either before throwing the switch, the cone was already shoved out, and then after throwing the switch, it relaxed back, or the other way around. It was relaxed, and when I threw the switch, it was shoved out. What is causing that? And is that normal? I mean, that's not normal in a normal speaker. That is absolutely not normal. It's the last thing you want to see, in fact. But you know, is this a normal speaker? It's built like a battleship. So that's a bit of a problem. Did anything get hot? Anything get hot anywhere during that time? Ice cold. She's cold. Pretty cold. Cold, cold, cold. Everything's cold. Can't feel anything over here. Now that I gotta pull this out. I don't want to be pulling this in and out all the time, but it sure is a rugged plug. Man alive. Like I said before, early USB. Flip this around. We'll take a look. Let's do this too. Be smart and cut the power off. Pull the plug out. take a look at the speaker. What are we dealing with here? When I first looked at the speaker, I thought, oh my gosh, this has been redone. This has been redone 3 times. This can't be original. This kind of material here. Put a little more light on it. It's really, really heavy. Heavy, heavy material. It has some kind of felt-like, it probably is felt, cloth here. And then this metal bracket, which is clamped down with the screws to hold the whole thing in place. Have some kind of central screw, which you don't normally find on speakers. This is original. I'm pretty sure this is the original speaker, the original cone. Nothing has been done to it. So, now there's a chance. I don't know what to think. Almost certainly this is the field coil, and it's part of the power supply. Used to filter out the AC hum after rectification. Very, very common in the early days. It's a handy place to put a big honking coil. And you might think, wait a minute, running the power supply power through the speaker, electromagnet basically, it's going to make the speaker hum. But for reasons I can't quite gather in my own head, that doesn't happen. So it's very common. Now, does that mean because this thing is drawing, or a current is being drawn through it, I don't know how much, probably, I don't know, half an amp maybe, quarter of an amp, 100 milliamps, I don't know. Some amount is being pulled through here. It's setting up a magnetic field within which the voice coil is supposed to travel back and forth. You take away the magnetic field and the voice coil's got nothing to grab onto. Probably would still make a little bit of sound because it can grab onto the magnetics of the metal here. Is there any magnetism left in this guy? I think they would make this of soft iron usually. Soft iron doesn't retain its soft iron. So there's a big weld point here and here. So they've made this part separate from the base. And then inside, it's hard. Can you see it on camera? Not really. I can look right in here, and there's a large metal ring. It looks like a large, what would you call it? Metal core running inside this coil, like a big honking chunk of metal. Would no doubt magnetically connect to this plate. This is another very large plate here. So you have very large, probably soft iron going around like this to make the magnetic circuit, and then a big iron core in the middle of this guy. And then that iron core is probably hollowed out inside somehow, in some way, for the voice coil to travel. And I know how it's done in more modern speakers. So back to the first question again, is that cone being pushed so far? I mean, it was pushed quite a distance, a quarter inch maybe, as much as a quarter inch. Is that okay? Maybe that's what happens. Maybe that happens to all these speakers. I wouldn't think so. I wouldn't think so. Think about it now. Yeah, that's what I'm trying to do. I'm trying to think about it. So you have this magnetic field generated by this, and the powerful metal magnet here, electromagnet. The cone should only move with the signal being applied to the voice coil. So if I'm witnessing the cone being pulled in, there's only a couple possibilities. One is there's something magnetic about the cone itself, like this screw here, or maybe there's a lot more metal in behind. I don't know what's in behind here. And it's just being sucked in or pushed out just by the power supply current. Just because there's already some magnetism in the coil, in the cone, some magnetic material, let me put it that way. On the other hand, it could indicate that there's a DC current flowing in the voice coil. So as soon as the field coil is energized, the voice coil pulls against it and the cone moves, and that's what I saw, and that's what I'm really quite worried about. That there's some kind of incorrect current flow in the voice coil. And, you know, the next statement that follows that is, and it burned it out. Now, the owner has told me he regularly listens to this. He plays records through it. He doesn't listen to the radio. Now, there's another thing maybe your eye has picked up on this. There's a great big burn spot here on this piece of paper. I'm guessing the burn spot has something to do with some soldering work. It has nothing to do with the coil or any event that took place during operation. But, you know, there's a lead wire going right under the burn spot. I can practically feel it traveling right up through here. So, I don't know what to make of that. Wow, it's a quandary, eh? So the situation is I'm scared now to operate this radio, considering what's happening to the speaker. You know, this is nearly 100 years old. It's 90 years old, and yet it's still intact. Should I be worried after 90 years of people doing stuff to this thing? You know, just because I'm coming along at this point, am I the guy who's going to blow it up? Not likely. But this thing is so rugged. Can also bet too. I mean, this is rugged. I mean, this is really a monster. Wow, this isn't going anywhere. That feels like it's rock solid. I saw this cone move. I wonder if it's set back all the way. And what I saw when I turned it on was it was thrust forward into its normal operating position where it's going to do its vibrating. And then when you turn off the set, it, for some reason, pulls all the way back and kind of hits a stop. That just sounds crazy to me. Okay, I'm going to do something I would never normally do, but this is so rugged. I'm going to reach around and try to pull the cone forward a little bit. There. You can see my finger deforming the cone here. No, this is not going anywhere. Oh! Oh my, okay. So, I'm just frozen in place here. Okay, so I'm just replaying this in my head. So when I stuck my fingers down further, there's another little pop just now. Down further here. Oh, there's another one. Oh my gosh. Okay, well, I don't think that qualifies as normal in any way, shape, or form. Of course, the set is off, so maybe this thing is in some relaxed position, and what it's doing now doesn't matter worth a hoot, because when I turn it on, it thrusts forward 1/4 inch and runs beautifully. Should we observe all this again? Should we make it instead of trying the radio, maybe I should really try to pump. Ooh, what was that? Something in my house just, probably some cat activity upstairs. Could try feeding a signal in, audio signal in. I'm going to think about this a little bit because this thing has got me really worried. And the last thing I want to say to the person who owns this is, and your speaker caught fire in my shop. I don't want that to happen. So I'm going to stop for a little bit and just think. Maybe I'll go see what happened in my house. We'll come back and decide what to do with this next. Well, just in giving it a little bit of thought and looking through the manual, the information about the speaker. So for the cone to be driven like I saw it, such a distance, it suggests to me that there has to be a current in the voice coil. And I don't think there should be any current in the voice coil. So one possibility is to disconnect the voice coil, lead wire, and see what happens after that. If this effect still takes place, then we know it has nothing to do with the voice coil current. So I was looking at the wiring here, and that's why I started up the cameras again, to show you what's there. So there's 4 terminals here. There's 2 upper and 2 lower. The 2 lower are connected to the field coil in here, and the 2 upper ones are hooked up to the voice coil. There you can see the voice coil leads. Was it just going through holes there? Look at that. That looks like pretty ordinary wire. So this early speaker, you know, like they didn't even curl the wires into a coil shape. They've left them here. They must flop around in those holes when the cone moves. That's really not very good. Normally these are really light braided wires. This looks like a regular insulated wire. That'd be really stiff into there. And they're not long. They just come through. They come through the back panel here and quickly make a connection back there. Huh. Well, it's early speaker technology. So some of the things I just would take for granted, I guess I hadn't really figured out yet. So that's one option. Disconnect these. One of these 2 wires here. Now here's what I wanted to show you. Down here. These 2 wires have been resoldered. They've been removed and tacked back on, or something like that has happened. You can really see it's quite fresh solder there. And this is not factory work. This is more like my kind of work. Look at there's a loose strand hanging out here. So it raises the question, why? Why would somebody remove these 2 wires? Did somebody remove all 4 of them and put them back wrong? That's what I'm really after, finding out. They just go into this bundle, and then they just come out onto the end of this plug here and disappear. So there is some information in the manual about wire colors, but yeah. Looks to me like these two go together, and these 2 go together. I think they're slightly different wire sizes. So that's good. So you see these 2 going together. Now what if somebody hooked it up backwards? What if somebody put the field coil leads to the voice coil? I don't think the speaker would be long for this world. I think the voice coil would be gone. But boy, would it drive it forward. If you hit the power, and if that were the case, the voice coil would rush forward. What are the chances of somebody getting this mixed up? Well, I know from my own experience, really good. Really, really good. You could even have reversed the direction of these 2 wires, even if these are the correct wires. The current flow through this field coil is DC. There's got to be an intention of which way these things should be connected. They may have been reversed. In fact, if you just look at the wires, you can see this one has a lot of slack in it compared to the other, and the slack one is the short one. So you think you put this one down here and the other one up here, and these 2 wires would be roughly the same length. So that's another factor. Maybe somebody booped it up. They may not have understood there was any consequence. I'm not even sure there's any consequence. Okay, what to do now? Let me peek in the manual and see what it says about these wires and their colors. It's a little hard for me to get it up on the screen, except to do the cheapest way possible. That's to put the camera on the screen here. Here we are. There's the wires. It says voice coil and field coil. Red with yellow. Oh, look at this. Black and white. Red with yellow tracer. Red with green tracer. Well, I didn't see anything like that. Definitely pointing at the wires coming in on the cable. Cable is showing strain relieved up at the top here, and that's exactly how it's done. It's been tied off up here at the top. Oh, look at this. There's a color up here I can see. Isn't that something? You know what? With my eye, I can't even pick up the green there. Except if I look really closely at it. But at a glance, I would never see the green. It's much easier on the camera. Okay, so there's a green-red one here. And this would be the black one. And I guess the white one would be the similar sized one. So, okay, so these two, I've got a green, and is there anything? There's yellow. I think I see a little yellow piece right there. Green and yellow. Now, what did it say on here again? Red with yellow tracer, red with green tracer. Isn't that interesting? The green and the yellow have sort of survived, but the red, you can't call these red. So anyway, I think that proves these are the field coil wires, and they are going down to the field coil terminals. By deduction, if that's the right term, then these are the voice coil. The voice coil is fed with an AC signal, so polarity here shouldn't matter. So I think the test here. Let's think about something else too. Now, how is it throwing that switch way over here? Throwing this switch would change the conditions in the speaker like this. So as far as I know, all this switch is doing is changing the input to the amplifier, which is really this tube way over here, changing the input to this tube from the radio output to the phonograph cartridge output. So it's just changing the input to this tube. And this tube amplifies a signal. It looks like my fingerprint on it there. This tube amplifies the signal, the audio signal, fires it into here. These are push-pull. 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 I wonder. Push-pull. Could an imbalance in the push-pull amplifier result in the cone being thrown way off? I can't quite see it. Well, I think the short answer, the stupid answer would be, well, yeah, something's wrong somewhere, maybe there. Again, I just don't think so. The signal, how does the voice coil signal get from these two tubes? Almost certainly through one of these great big transformers here. If the output of the amplifier tubes is going through a transformer, there is no DC left to push the cone on the speaker. Okay, you know what? We got to take a look at that. Let's take a look here. Come with me. Come over here. What can we find out about? Just 1 second here. Just watch this for a moment. I'm just going to change the focus. Focus. Changing the focus back a little bit. About like that. Good. Okay. Good enough. Back to the manual. Okay, sorry about doing it this way, but this is really super convenient for me. So we go up here to I was going to look at how is the speaker connected. Well, it won't be off of this. This is the radio. I need the amplifier. There's the speaker terminal and everything. And just showing you what's in some of the boxes. This is actually a circuit. They say if you don't have a oscillator, here's one you can build. Can you believe it? To start it up, control layout, or the neutralizing. Look at this thing. So this is required to do the neutralization. As far as I know, I haven't read this fully, but I took one look at this and oh my gosh, this is the test setup for doing the neutralization setting. Hope not. Still going at it. So here we are. This is the amplifier. Wait, this isn't going to help. This isn't going to help. I need the. Come on, man. I need the schematic with the speaker connections. Oh, there's a speaker right there. Interesting colored interference on my picture. Electrodynamic speaker. Oh my god, yeah, I gotta trace all those wires. So, no I don't. A bunch, you see, a bunch are coming from there. Okay, so this is what I'm really after. Here's the push-pull amplifier. And you see how there's an output transformer, and then the wires just come over and go straight to the voice coil almost certainly. What else could they do? How can you get DC in that? You get DC in that from wiring errors. I mean, actually this is all isolated in fact, isn't it? Unless they've done something, the whole output from that transformer is isolated from everything else. The defect in the output transformer short from the primary to the secondary, juicing up the voice coil. I don't know. Okay, but there's nothing unusual about how this is done. This is your standard push-pull type setup. Okay. Okay. Now, so I think a harmless option would be to disconnect one of the voice coil wires and repeat the test. But before doing that, we should repeat the test, see the cone move. As hairy as it is to watch, let me move this like this. See if I can get the big honking plug back in. Okay, plugs in. Ah, man. Okay. Now, what I want to do, so the effect of this thing jumping occurred when I threw the switch, but I don't know if I was energizing it or de-energizing it, if it was being driven or relaxed. I don't know what was what because I wasn't watching it. This is certainly in its relaxed position now. Oh. Oh my gosh. Son of a gun. Oh boy. Oh man, what is making that noise? Wow. Okay, let's go back to taking a close look at things here. So to me, the voice coil is rubbing something horrible in the speaker. Just give me a second here to figure out how to get a camera into here. There we go. I think this might work. Whoop. Get in there without breaking it. I actually got it in there. Good show. Okay, get it aimed right. Perfect. Almost perfect. Okay, let's fix the focus on it. And we're going to have ourselves something good to look at here. So right in the bottom of the picture is where the voice coil enters the cone. You can hardly see it there. Now I'm going to move it by hand again, as kind of high anxiety as it is. So you can see the lead wires, voice coil lead wires, they're sliding in those iron holes. Actually, you can see, look at the one at the top left. The insulation has broken on it, and there's probably a bare conductor in there. Now, let's see if I can get a little better look at the cone here. I gotta hold that. Yikes, I'm short on light here today. There. Ah, perfect. There we go. Now hold that and hold this. Look at the dirt and crap in there. Oh. Whew. Well, I really think, certainly if the cone is operating in this position, this is what you're going to hear. If the cone is being driven way out, what is that crap in there? Or is it being driven way in? Okay, so it can't go in. It cannot go in. So guess what? This answers the question of what happened here. It can't go in any further. So it must have been popped out. Pop it out. Oh, look at the iron. So can see the iron filings that are sliding around. You know what, this guy's got to be cleaned out. Boy, 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 boy. So my thinking here is the cone has to be removed entirely from the speaker to fix this. This speaker is better than some of the newer ones because I think I can just remove this iron bracket and the cone's going to come right out. I'll disconnect these wires up here. I can put better wires in there. Take the cone out, clean it all up, put it back in. How do you get it centered again? This is the part that freaks me out. Apparently, according to the instructions, you tip the speaker looking face up, you loosen up the screw, you then tighten up that screw, and it's in the center. Really? How would that make it go in the center? Only if it's centered all the way out here, I would think. So what is controlling the centering out here? So if I were to put it back together, probably there's very distinct signs of exactly where this edge occurs, because there's going to be a dirt line all around here. I probably can't put the cone, kind of get it right. This is one continuous piece of steel. It's split here. This whole band. So now operating the speaker in this condition. So now the speaker has two things going on. One is filthy, dirty voice coil slot with flakes of rust and whatnot in there. That's one problem. And the other problem is this thrusting of the cone. We should explore that a little further, I think. It takes time to burn things up. Maybe if we're quick, we won't burn this guy up. And there's a good chance it's been operating this way. The owner has been operating it this way. The cone jumped out, or whatever it is that's going on. So I'm not going to bother with anything but this speaker deal. So we'll apply power. I can't remember which position the switch over there was in. That, I mean, well, it doesn't matter. Which position is it in right now? Let's put it in radio position. Okay, I think that's radio position. So we turn it on. We watch this cone very carefully in case it gets pushed out as the radio warms up. Now flip the switch. See which way the cone goes. At this point, it has to come out. I don't think it can go in any further. Okay, I think that's it. Checking on the power situation here. We can do this with restricted power. No, we can't. We can't make the tubes light up with restricted power in this unit. Not with. I got to put bigger light bulbs in there. Okay, but we will start it with restricted power. Okay, and the set is off right now. Okay, I'm going to throw the switch on the set. There's our light bulbs. What's this cone doing? Did anybody see anything? I wasn't even watching. Probably would hear it. If it gets shoved out, we would hear it, I think, because of all the noise it would make. Now the tubes have not warmed up, so there's no tube conduction. So, but potentially when I throw the main switch, that's when the speaker will be pushed. Okay, watching very carefully now. Here we go. Yeah, I don't see anything happening at all. As far as I know, that cone is sitting right rock bottom. Okay, so what we'll do now is we're going to throw the switch here. In fact, you know what? A much better view would be this one. So I'm going to throw that switch. And I don't want to do this more than once. What happens when I do this? Wow. Okay. And what happens when I do this? And one more time, please. And back. Okay, that was an interesting thing. Now, before I get too excited here, down on the power. Okay, so what's happening there? Seemed to me as I threw that switch, there was a point in the throw that sent a shock to this thing. You notice it jumped, and then it receded to wherever it would relax to. It's actually out a little bit right now. Only because I think iron filings are holding it there. So let me just push this a little bit and see if it doesn't pop back. There, just pop back. Well, one of the things the owner said to me was he wanted this thing sounding really good. We're never going to get there with a speaker like this. It doesn't matter what I do to anything else here. So I think it's all about the speaker, at this point anyway. So, I think I'm on my way to pulling the cone off of this and doing all that stuff. I don't know what else you could do. That's something new for me. I've never done that before. I tried to stay away from it. Simply out of fear of never getting it back together right again. But the fact is it's not right now. And this is a really rugged cone. I think I could take it off and practically stand on it. So maybe this is a good speaker to do this too. For the first one for me. Okay, I think that's about it for today. I'm not going to do any more. I'm going to spend my day researching and thinking about how to do this before I commit myself. But probably tomorrow is a video about this speaker coming apart. Thanks for watching.